All right, so lesson lucky number 13. We're going to talk today about the reciprocal of sine, cosine, and tangent. All right, every number has a reciprocal, so sine, cosine, and tangent will have one as well. First, I'm going to talk about what a reciprocal is, and then we'll go from there. So let's start by just looking at some basic numbers. So right here, I'm going to put the number, and over here, I'm going to put its reciprocal. All right, so for example, if you have the number 3/4, all right, the reciprocal means you're going to take the fraction and you're going to invert it, you're going to flip it. So the reciprocal of 3/4 would be 4/3. All right, well, what do you do if the number is a whole number like 7? What is 7's reciprocal? Well, you would have to take the 7 and treat it as 7/1, and then when you flip it, it's 1/7. All right, so that's how that works. What would the reciprocal of x be? Well, x is really x/1, so its reciprocal would be 1/x. So how does that tie in with what we're doing in trig here? Well, we're going to talk about what the reciprocal of sine, cosine, and tangent are. All right, so let's look at that real quick. If I wanted I'm just going to use theta for my angle here. I have the sine of theta, the cosine of theta, and the tangent of theta. And I'm going to find their reciprocals. Well, remember, each one of these is really over 1. This is really sine theta over 1, cosine over 1, and tangent over 1. So their reciprocals are just going to be those inverted or flipped. So the reciprocal of sine is going to be 1/sine. Cosine is going to be 1/cosine, and tangent is going to be 1/tangent. However, those three reciprocals have special names, and these are new names that you haven't seen before in any of your work in trigonometry. This 1/sine right here has a name, all right, and so does 1/cosine and 1/tangent. So I'm going to erase here and rewrite and introduce you to those new names. All right, the reciprocal of sine is 1/sine. All right, it has a special name. The reciprocal of sine is called cosecant. Spelled like that. We do abbreviate it though. We use CSC. So the cosecant of theta is the reciprocal of sine. All right, we'll get back to that in a minute. Let me just introduce you to the other two. The reciprocal of cosine is 1/cosine. Its reciprocal is called secant, and its abbreviation is SEC. So the secant is the reciprocal of cosine. Tangent's reciprocal is 1/tangent. It has a name. It's called cotangent. Cotangent. And we abbreviate that COT. So these are the three reciprocals. They're the reciprocals of sine, cosine, and tangent. They have special names. Now I know probably right now some of you are thinking, why wouldn't cosecant go with cosine and secant go with sine? There are reasons for that, all right? And I don't want to get into that long explanation right now and confuse you with all these diagrams and things. If you're really interested and want to know about it, you can Google it or go on YouTube and just type in why is sine equal to cosecant or something to that along those lines, and you probably will find something on that, all right? But either way, you guys need to know which one goes with which. Cosecant with sine, secant with cosine, cotangent with tangent. All right, those are the reciprocals. So now let me show you how we use the reciprocals. So I had to take a quick break in the action. Look who showed up while I'm trying to teach. Say hello, Copper. At least he's not out of the yard. He's actually here, which is good. All right. Okay, anyways, we'll get back to the reciprocals here. All right, so here is our first example of using these reciprocals. Notice I have my 45, 45, 90, my 30, 60, 90, my unit circle drawn. That's not going away. We're still going to utilize that. Just have a slight little different stuff we got to do here at the beginning, that's all. So this first question here is asking you to find the cosecant of 30 degrees. We need to remember that cosecant is sine's reciprocal. So what we're going to do is we're going to first find the sine of 30 degrees. So let's do that. That's something we've been doing. We can handle that. We go over to our 30, 60, 90 here. Sine is opposite over hypotenuse, so the sine of 30 is 1/2. Now remember, we wanted the cosecant of 30. Cosecant is the reciprocal of sine. So if you take the answer you got for sine, which is 1 over 2, and flip it to its reciprocal, which is 2 over 1, that's going to be the cosecant of 30. It's going to be 2 over 1, or just 2. That's the only difference between these reciprocals and what we've been doing. You have to first find the sine and then flip your answer over to get the cosecant. So there's our first example. I've got a total of 6 of these that I'm going to do. There's the first one. I've got 5 more. All right, our next one is the cotangent of 60. Cotangent is tangent's reciprocal. So I'm going to first find the tangent of 60. I can get that from my 30, 60, 90 triangle right here. Tangent is opposite over adjacent. So radical 3 over 1. But we want to now flip that answer because we wanted the cotangent of 60. So I take radical 3 over 1 and I flip it to 1 over radical 3, and that's going to be the tangent, or the cotangent of 60. All right? All right, this one's a little bit more complicated, not too much. If I want the secant of 315 degrees, secant is the reciprocal of cosine. So I want to first find the cosine of 315 degrees. To find the cosine of 315 degrees, I got to first find its reference angle. So let's do that work down below here. 315 sits right there, has a reference angle right here of 45 degrees. So the cosine of 315 is the same as the cosine of 45. The cosine of 45, from your 45, 45, 90, adjacent over hypotenuse or adjacent over hypotenuse, doesn't matter which one, it's 1 over root 2. But ASTC, we got to check that real quick. We are in the C quadrant, and cosine is positive there, so we're good. We leave that as a positive 1 over radical 2. Now remember, there's one more step here though, because the original question wanted the secant. Secant is the reciprocal of cosine, so I need to take this answer and flip it to radical 2 over 1, or just radical 2. And that is my final answer. I got 3 more to do. I chose these last 3 because they deal with 90 degrees, and I just want to show you how it works with 90, because when we're dealing with 90, we're dealing with this 1 and this 0 here, and I want to show you how that works. All right, so this one, first of all, is in radians. So I want to first take it out of radians and get it in degrees. So I'm just trying to tie in some of the stuff that we've been doing previously. So if I just off to the side here real quick, go down here where I've got some room. I hope you can see right here. Yeah, I think you can. If I take pi over 2 and multiply by 180 over pi, my pi's cancel. 2 goes into 180 90 times. This is a 90 degree angle. So I'm actually looking for the cosecant of 90. So to do that, I need to know that cosecant is the reciprocal of sine. So I need to find the sine of 90 first. Where do I get the sine of 90? Unit circle. All right. Unit circle, right here is 90 degrees. Sine is your y value. So the sine of 90 is 1. Now 1 is really 1 over 1. Now remember, the original question was the cosecant of that. Well, when I take the cosecant, that means I have to take the sine and flip it. Well, when I flip 1 over 1, I still get 1 over 1. So sine is cosecant and sine are kind of unique because their reciprocals are the same. The reciprocal of 1 is just 1. So nothing changes here, and the final answer is still just 1 over 1 or 1. So the sine and the cosecant of 90 are both 1. All right, so next I'm going to do the secant of pi over 2. We already figured out what pi over 2 is in degrees. I'm not going to redo that again. I have the work still on the board here, didn't erase it. But we all know that pi over 2 is 90 at this point. So secant pi over 2 is the same as the secant of 90. Secant is reciprocals with cosine. So I got to find the cosine of 90. The cosine of 90, I'm going to go to my unit circle. Cosine is your x value. The cosine of 90 is 0. Now, what we don't realize sometimes is that 0 can be written as a fraction. 0 is really 0 over 1. Now, what were we ultimately trying to find? We were trying to find the secant of 90. To do that, we find the cosine of 90 and we flip it. Well, the cosine of 90 is 0 over 1. And when I flip that, it becomes 1 over 0. We've seen that before. 1 over 0 is a problem because I can't divide by 0. So this ends up being undefined. So you actually can't find the secant of 90 because it's undefined, because when you flip the cosine, it gives you a 0 in the denominator. I want to show you one more with pi over 2, and then we'll be good. All right, the cotangent of pi over 2. All right, we know pi over 2 is 90, so this is actually the cotangent of 90, which means we're going to find the tangent of 90, because cotangent and tangent are reciprocals of each other. So if I find the tangent of 90 and flip it, I'm good. Now, the tangent of 90, remember, tangent is sine over cosine. So this is the same as the sine of 90 over the cosine of 90. And when we do that on our unit circle, the sine of 90 is 1, the cosine of 90 is 0, and it's 1 over 0. And normally we would say that's undefined. And it is if it's tangent. But we're finding the cotangent of 90. Remember, we were trying to find the tangent first, and then we're going to flip it to get the cotangent. So it is undefined right now, but when I flip it, it becomes 0 over 1, which is no longer undefined. 0 over 1 is just 0. So I can find the cotangent of 90. The tangent of 90 is undefined, but when I flip it, it's not undefined anymore. So that's a little tricky. All right. Let me know if you have questions on the homework. Go Niners.